Hello, everyone, and welcome to Ready, Set, Go Stata. Today, I'm going to introduce you to Stata's tools for data management, graphics, and some basic statistics. Perhaps more importantly, I'll also show you how to find information on tools I don't cover today, so you know where to look for help as you work through your own projects. Let's get started and open Stata. What we're looking at right now is the main Stata interface. If you're on a Mac, you might need to change your layout to widescreen through the View menu if you would like your interface to look like this. At the top, we have the menu system we can navigate through, starting with File, to change your directory or load a dataset, Edit, to change the look of Stata or the language, Data, to describe or manage your data, Graphics, to create basic or more specialized graphs, like those for panel data or time series, and of course, Statistics, to make tables, test hypotheses, fit models, and much more. Below that, we have the Results window, and at the bottom, we have the Command window. In Stata, we have two equivalent ways you can perform tasks. You can point and click using the dialog system, or you can type commands. Either way, you'll see the same command and output in the Results window. For example, I can use the Display command to say, "Hello," and see the command in the Results window with a period in front of it and the output below. On the left, we have another window called History, where you can look at the commands you've issued in this session. We can re-execute them, copy them, or even send them to a do file to save your work. We'll do that toward the end of our session today. On the right, we have another two windows. The top one is the Variables window, where you can see a list of variables and their descriptions. And below that, we have the Properties window, where you can change labels, formats, and more. Right now, we don't have a data set loaded, so these windows are blank. Let's change that. I'll start by navigating to my desired working directory. This is the folder on my computer with the files I would like to use for this demonstration. You can do this with the cd command or through the menu system. I click File, Change Working Directory, then select Documents, RSGS. I can type dir or ls in my command window to see what files are in my current working directory. If you already have a Stata dataset, that is, a .dta file, you can just type use in the name of the file. Now we see the names of each of the variables and labels describing that variable. If we click on a particular variable, we can see its properties as well as the dataset properties below. We also have several example datasets installed with Stata or accessible through the web. Just click File, Example Datasets, and then I'll click Example Datasets installed with Stata. Let's use the classic dataset installed with Stata called Auto. We click Use, and then let me close this window, and you can see this has issued the sysuse command and repopulated our variables and properties window. If you have a dataset that is not a DTA file, you can import data from other sources. Just go to File, Import, and select the dataset format. For example, we can import an Excel spreadsheet. This opens the dialog box for the Import Excel command. We click Browse and locate our dataset. I'm going to select my NLSW 88 spreadsheet, that is, the National Longitudinal Study of Women in 1988, and click Open. In the preview, we see that our dataset has variable names in the first row, so we check the box Import First Row as variable names, and click OK. I get this message asking me if I would like to replace the current dataset. In Stata, we can only work with one active dataset at a time. We could use something called frames to work with multiple datasets, but we're not going to do that today. So I click Yes to clear out the auto dataset in order to read in the NLSW dataset. This issues the import Excel command, which imported 11 variables and 2,246 observations. We can see the variables we imported on the right in the variable window. ID code, age, racial category, all the way down to tenure. To take a look at this dataset, we can open the data editor using the shortcuts that look like spreadsheets on the top left. The icon with the pencil is the edit mode, and the one with the magnifying glass is the browse mode. Let's start in browse mode. Here we see we have some demographic information about each person in this dataset, as well as an occupation code and information on union membership, hourly wage, average number of hours worked per week, and tenure. That is, years of experience in that occupation. Right now we have the wage variable measured in dollars per hour. Perhaps we would like to generate a new variable of the natural logarithm of hourly wage. To do this, we go up to the menu system, click Data, Create or Change Data, Create New Variable. This brings up the dialog box for the Generate command. Notice that our dialog boxes have these three buttons at the bottom. Help opens the help file for that command. We'll go through a help file later today, so I'll close this for now. The second button resets the dialog box. That is, if I start typing and selecting options in the dialog, and then later decide I want to start over, I can click the reset button, and it's like opening the dialog box for the first time. The last button, Copy, copies the syntax this dialog would have generated without actually running the command. Let's get back to what we were doing. Remember, we would like to create a variable that is a natural log of the wage variable. We start by specifying the variable type to be generated. We'll just leave it as a float, but if you want more or less precision, you can change that here. Next, we need to give the new variable a name. I'm going to call it ln_wage. Then we need to define this variable by typing in a value or expression. If you are new to Stata and you're not familiar with expressions, just click Create, and that will bring up the expression builder. You can use operators or functions to manipulate variables, coefficients, or even estimation results. We're interested in functions, mathematical, and then we scroll down to ln. We see at the bottom, it tells us that this is the natural logarithm function. When you double-click on it, it will populate the expression at the top with lnx. So now we just need to change the placeholder x to the variable we would like to take the natural log of. So we select Variables, scroll down to Wage, double-click it, and click OK. If you're already familiar with Stata expressions, you also could have just typed ln parentheses wage. I'm also going to change the position of this new variable. Rather than adding log wage to the end of my dataset, I'm going to insert it after the original variable by selecting Insert after specified variable, and then specifying wage. Click OK again. Now we see our new variable we just created, ln wage, where 2.46 is the natural log of 11.7, 1.856 is the natural log of 6.4, etc. If we would like to add a label to this variable or make any other changes to our variables, we need to open Edit mode. Even if I try selecting ln wage and typing in a variable, nothing happens because we're in Browse mode, which is for safely looking at your data without accidentally modifying it. We switch over to Edit mode by clicking its icon in the top left corner. We get this prompt from Stata asking us if we're sure we want to switch over. We click Yes. Now we know we're in edit mode because we can manipulate data properties. Let's add a label to our new variable, log of hourly wage measured in dollars, and press enter. Let's also change the label for tenure. This is job tenure measured in years, so let's add that information to the label. What about union? This is actually a factor variable indicating whether each woman is a union member. 1 indicates that she is in a union, 0 indicates that she is not. The periods or dots indicate missing values. I'll start by changing the variable label to union membership, and then I also want to add value labels so that the values of 0 or 1 actually mean something. We go to Value Label in the Properties window, and we click the downward arrow to select a label, but we don't have any available. So first we need to create one by clicking the ellipsis. This opens the dialog box for the Value Label Manager. We start by clicking Create Label and giving this label a name. I'm going to call it Yes No. Then below, we associate labels with values. I'm going to label the value 0 with No, enter, and the value 1 with Yes, enter. Then I click OK. Now we can see Yes, No in our list of value labels, and if we expand it, we can see the particular labels. We're ready to close this Value Label Manager now and assign this new label we created to the variable union by again navigating to the Value Label field and expanding the drop-down menu, this time selecting Yes, No. Now, pay attention before and after I attach the value label. Before I attach it in the data editor, we just see the value in black font, 0 or 1. After I attach the value label, we see these labels in blue font, no or yes. If we click on a particular cell, we can see the value it's stored as above. We're just displaying it in a more meaningful way. Let's do the same thing for the call grad variable, which is an indicator for graduating from college. First, I'll change the variable label to graduated from college and use the value label drop-down menu to, again, select the yes/no label. We see that this variable is now displayed as no's and yeses instead of zeros and ones. Note that when we manipulate this variable in the future, we will still refer to zeros and ones because that is how this variable is stored. We've just changed how it's displayed. Alternatively, you may have factor variables that have been stored as strings rather than as numbers. Take a look at the racial category variable. It is displayed as words and red font. If I click on a cell, I can see that it is not being stored as a numeric value, but as a string. If we would like to use this variable in our statistical analysis, we will need to convert it into a numeric variable, but we would also like to keep these strings and use them as value labels. We can accomplish both tasks in one step by navigating to the Data menu, Create or Change Data, Other Variable Transformation Commands, and Code Value Labels from String. This brings up the dialog box for the Encode command. We can convert the string variable raceCat into a numeric variable we would like to call race. Let's click OK and see what happens. We still have our original variable raceCat, and then at the end of the dataset, we have our new variable, race. These two look very similar. The only difference is that race is displayed in blue font, and if we click on a cell, we see its underlying numeric value. Furthermore, if we open the Value Label Manager, we see that a new value label, race, was also created. Now, I'm happy with the rest of my variables for now, so I'm going to exit out of the data editor and return to the main interface. We can see in the History and Results window that we have run several commands from inside the data editor. we see the commands that generated our new variable, labeled variables, added value labels, and encoded racial category. Once you become more familiar with Stata, you may prefer to just type these commands to save time. If you do ever forget a command, you can always return to the point and click method. Regardless of how you have run Stata commands, you can always save a record of what you have done by navigating to the History window and selecting the commands you would like to save. You can use the Control key to select commands that are not grouped together, and Shift for commands that are grouped together. I use Shift to select all the commands from Import Excel down. Then I right-click and Send Selected to the Do File editor. Now we see what we call a do file, which is a script of Stata commands that we can save and run, or to use Stata language do anytime. I'm going to erase the file pathway from the Import Excel command so that in the future, as long as I'm in the same directory as this Excel spreadsheet, whether on this computer or another, my script will work. To make this script reproducible in future versions of Stata, we can use version control by adding version and the current version number to the top of our do file. This ensures that your do file or program will continue to run in all future versions of Stata, even if that future version has changes in the syntax you use. I'm finished with this do file for now, so I'm going to save it as nlsw.do and return to the main interface. To demonstrate how we could use this file in the future, I type clear to clear the current dataset we have imported and manipulated. Looking at the variables window, we can see that it is empty because we have no dataset loaded. To reproduce the work we have done so far today, we can simply type do nlsw. And we see that it has re-executed all the commands we have previously run to create our dataset. When I open the data editor, I see that all our variables are as they were before. We have attached value labels, encoded racial category, and added variable labels. Rather than rerunning these commands each time we want to use this dataset, we could also just save the current dataset as a .dta file that Stata can load directly next time, either by using the Save command or by clicking File, Save. I'm going to call this dataset NLSW88. Now that we have finished all the data management we would like to do, let's explore our data a bit through tables, graphs, and other tools. We'll start by going up to Data, Describe Data, and selecting Describe Data in Memory or in a file. In memory means the current data set that we have loaded, whereas you can also take a look at data you haven't loaded yet in case you're trying to figure out which data set you want. I want to use the default options, so I click OK. And we see that this has issued the describe command. The output from this command tells us that we have 2,246 observations for 13 variables. And then it lists each of our variables along with its storage type, display format, value label, and variable label. To see more detailed information about each variable, we return to the Data menu, Describe Data Contents. This is the dialog box for the codebook command. We can leave the variables field blank to list all variables or select particular variables. I'll select age through callgrad and click OK. This created a lot of output, so let's start by scrolling to the top. We see that the codebook command outputs a box for each variable with a variable name, variable label, variable type, range, number of unique values, number of missing values. Then, if it's a continuous variable, it shows the mean, standard deviation, and percentiles. Whereas if it's a string variable, it shows frequency counts for each unique string. If it's a numeric variable with less than 10 unique values, like callgrad, It shows us a tabulation of its values and the associated value labels and value label name if one has been attached. To just get a table of summary statistics, we go back to the Data menu, Describe Data, Summary Statistics. This brings up the dialog box for the Summarize command. Again, we can list all variables by leaving the variables field empty, or we can type specific variables, ranges of variables, like we did before, or patterns. Perhaps I want to see summary statistics for wage and the natural log of wage. I type asterisk wage, meaning any variable name that ends with wage. We click OK and see that this issues the Summarize command, which shows us summary statistics for wage and log wage. For factor variables, rather than computing summary statistics, you may want to create a tabulation table with frequencies and percents of categories. There are a few ways to do this in Stata. All of them can be accessed through the Statistics menu, Summaries, Tables, and Tests. We'll start by selecting Tables of Frequencies, Summaries, and Command Results. This opens the dialog box for the Table command. This command was reimagined in Stata 17, so if you have an earlier version of Stata, your dialog box will look different. We can start by selecting Union as the row variable and callgrad as the column variable. This time, we're going to select Submit rather than OK, so that the dialog box stays open. We see that we issued the Table command, which outputs a cross-tabulation of union by college graduation. For instance, we see that this dataset has 148 women who graduated from college and joined unions. Overall, 461 women in our sample were in unions, while 1,417 were not. Maybe instead of frequency counts, we want to see means of wage by each of these combinations of union and callgrad. We can create tables with many types of summary statistics using the dialog box by navigating to the Statistics tab. We click Create, Summary Statistics, and we see that mean is already highlighted, though there are many other options here. Below, we select the variable or variables that you would like to compute means for. I select wage, click Accept, and then I click OK to run this command and close the dialog box. Again, we see our table command, this time with the statistic option specified after a comma. From here, we can see that wages are higher on average among college graduates, and it looks like union membership influences wage more among workers who did not graduate from college. Another way we could look at summary statistics by a grouping variable is with the dtable command, introduced in Stata 18. To access this tool, we can either navigate through the Statistics menu once more, or we can type db dtable to open its dialog box. At the top, we list variables that we would like summary statistics of using the drop-down menu. For factor variables, we can click the ellipsis and then select Union, Add to var list, and Race, Add to var list. Notice that both variables were added to the list of variables with an I dot in front of them to signify that they're factor variables. We click OK. We also could have just typed tenure hours I.union, I.race. Let's start here and click Submit. We see a table with total sample size, means and standard deviations of our continuous variables, tenure and hours, and frequencies and percents of each category of factor variables, union and race. We could specify other statistics using the Continuous and Factors tab in the dialog box, but we'll keep these default statistics. I do, however, want to add a grouping variable by selecting Describe Variables by Group, and then I select callgrad from the drop-down menu and click OK. This added the By option to the dtable command. Now we can see sample sizes and summary statistics for non-college graduates, college graduates, and everyone. We can also explore our data visually using Stata graphics. We start by navigating to the Graphics menu and selecting Histogram. This opens the dialog box for the histogram command. We select the variable we would like to draw a histogram for and click Submit. Note that if you have an earlier version of Stata, your graph may look different because we changed our default graph scheme in Stata 18, but it will still be the same plot. Looking at our distribution, it looks pretty normal, but we may want to add a normal density to this graph to see how it compares. Returning to our dialog box, we click the Density Plots tab and select Add Normal Density Plot, and click OK. We see our same plot, but with a normal density curve added on top. Now let's look at the relationship between wage and tenure with a scatter plot. Again, we navigate to the Graphics menu, and this time select Two-Way Graphs. This is the dialog box for Two-Way. Two-Way is a family of plots, all of which fit on numeric Y and X scales. You can use Two-Way to create several types of plots, overlay plots, or fit them separately by group. We would like to create a simple scatter plot, so we click Create, and we see that scatter is already selected. Below, for the Y variable, we use the dropdown to select log wage, and then select tenure as our X variable. We click Accept and Submit. We can see that there seems to be a weakly positive linear relationship between these two variables. To help us better visualize the linear relationship, let's add a line of best linear fit to our graph. Returning to the dialog box, we select Create, choose Fit Plots, and we see that linear prediction is already selected. Again, we use log wage as our Y variable and tenure as our X variable, and click Accept and Submit. Now we see a red line of linear prediction has been overlaid on top of our scatter plot. To see this line more clearly, we may want to thicken it by going back to our dialog box and making sure Plot 2 is selected. Click Edit. Then at the bottom, select Options, then Line Properties. And for width, let's use Thick. Accept, 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 Submit. We can see the line of linear prediction much easier now. As a final step, let's create subplots by college graduation status by returning to the dialog box and navigating to the By tab and selecting Draw Subgraphs for unique values of variables. I use the dropdown to select CallGrad and click OK. Now we have two plots, one for each level of CallGrad. To make further customizations, we could continue to use the dialog box or commands, or we can open the graph editor by clicking the button with a pencil over the bar graph. From here, we could click the legend and right-click to hide it, change colors of the dots or lines, or any number of other customizations. When we're finished, we can save this as a .gph file, a Stata graphics file, if we would like to modify it more in the future, or we could export it as a high-quality image or PDF file. Now that we've finished modifying our graph, let's close the graph editor and do some statistics. When we clicked the Statistics menu previously, you may have noticed that we offer a long list of tests and models in Stata. Under Summaries, Tables, and Tests, we have descriptive statistics, like means and correlations, classical tests of hypotheses, like t-tests, z-tests, and effect sizes, and below that we have non-parametric tests. Under Linear Models and Related, we have regression, ANOVA, even mixed effects, and Bayesian regression. Today we'll stick to a basic linear regression model. This is the dialog box for the regress command. For this analysis, we would like to explain differences in wage by job tenure, controlling for other factors. We begin by selecting log wage as our dependent variable, and then we could use the drop-down menu to select our independent variables, type them in this field, or click the ellipsis. This time, I'm going to add a two-way full factorial with union and tenure. I start by selecting union, then tenure. Because tenure is a continuous variable, I select the C dot box. When we add to var list, we see that it added term union ## or ## C.tenure. The double hashtag means that it will add the main effects of union and tenure and their interaction all in one step. We select OK. Notice that when we're adding main effects, we need to specify factor variables with an I dot, whereas when we're adding interaction effects, we need to specify continuous variables with a C dot. Select OK. We can see that we have fit a linear model regressing wage on hours, call grad, union, tenure, and their interaction. At the top, we see our ANOVA table with our model, residual and total sums of squares, degrees of freedom, and mean sums of squares. To the right, we see that this analysis was conducted on 1,867 observations. Why not 2,246? Because union has some missing data. So because we included that variable in our analysis, by default, Stata uses listwise deletion to perform complete case analysis. Below that, we see our overall F statistic in its p-value. This tells us that there is a significant difference in the variance explained by our model versus the intercept-only model. Below that, we see our R-squared, adjusted R-squared, and root mean square error. In our coefficient table, we have our estimated regression coefficient, standard error, t-test and p-value, and 95% confidence interval for each term in our model. If you're unsure how a factor variable was coded, we can see the base level by coming down to the command window, clicking the Page Up button on your keyboard, or Function Up arrow on a Mac to retrieve the most recent command, and adding comma base. Enter. Adding the base option shows us that non-union is the base level of the union variable. Therefore, the regression coefficient we have estimated is comparing union members to non-union members. After fitting this model, we may want to visualize these results. In Stata, we call everything you do after fitting a model post-estimation. To see what's available, we navigate to the Statistics menu and go all the way down to Post-Estimation. This opens the Post-Estimation selector. From here, we can make predictions, do diagnostics, perform tests, and more. Today, I would like to show you how to create an interaction plot using marginal means. So we expand marginal effects, marginal means and interaction analysis, navigate to interaction plot, and double-click it. This is the dialog box for the margins command. Here, we need to specify the two variables and their interaction effect we would like to visualize. Let's start with our continuous variable, tenure. So we select continuous, tenure, and then we need to specify values to compute estimates. You may have hypotheses about specific levels of a continuous covariate, or you can just specify a plausible range of values. Let's do the latter. We'll compute estimates at 0, 5, 10, 15, 20, and 25 years of experience. Alternatively, if you have a range like this with equal distance between each value, you could just specify the first value, in parentheses specify the step size, and then the last value. Then we specify our categorical variable union and select OK. We'll come back to this plot in a moment. First, let's take a look at the output. In the results window, you can see that we have run the margins command to compute marginal means at each level of union at each specified value of tenure. Below that, we see a key for the results table below, where 1 indicates tenure equals 0 years, 2 indicates 5 years, and so on. The coefficient table lists margins, that is, average predictions from our model when we set union and tenure to each of these combinations, and their standard errors, t-tests, and confidence intervals. We can interpret this first row as the expected log wage for someone who is not in a union and has 0 years of experience. The second row is the expected log wage for a union member with 0 years of experience. The next 2 rows are the expected log wage of someone with 5 years of experience, and so on. We can bring up the plot again by clicking the shortcut at the top that looks like a bar graph. Here, we can see this interaction effect more clearly. Both groups increase their expected wage as their job experience increases, but union members start at a higher wage and increase their wage more slowly as they gain experience. In other words, union membership is moderating the relationship between tenure and wage. Now that we're done with our analysis, I'm going to select the remaining commands from the history window, right-click, copy, and add them to my do file. I can click the shortcut with the paper and pencil on it to bring up my do file again. Now I paste and save so that all of you can have access to it. Before I go, I want to make sure you know how to find all the tools you need for your analysis. Rest assured that although today I just showed how to do a linear regression model in Stata, other types of regression work similarly. Let's say you have a binary outcome and want to do a logistic regression. If you're not sure which command to use, you can use the dialog boxes by navigating to Statistics, Binary Outcomes, Logistic Regression. Or you could try searching for it in the command window by typing Search Logistic Regression. What we call the Viewer window pops up and lists everything Stata could find with the keywords Logistic Regression. First, we see an overview of Stata estimation commands, and below that, we see entries for logistic regression and post-estimation tools for logistic regression. If we click Logistic, it navigates us to the Help menu for the Logistic command. At the top, there's a link to the PDF of our documentation. You do not need an internet connection to open these files. They're downloaded with Stata, though you can also access them from the web rather than Stata. I'll show you that in a bit. The documentation has a lot of the same information as our help files, but in much more detail, including fully worked examples and methods and formulas for all our estimation commands. Closing this for now, let's return to the Help menu. The first information we see is the syntax for how to use the logistic command. Like regress, we first list the dependent variable, followed by the independent variables. In fact, this syntax is used across all regression commands in Stata. Across all commands, we can add options after a comma. We see a list of possible options for this command below. Under that, we have a paragraph with more information about the syntax, including which prefixes and types of weights are allowed with this command. Below that, the Help menu tells us how to find this command through the menu system. Then, we have a short description of the command and links to specific entries of the PDF documentation, such as methods and formulas. Then, we have more information about each of the command options. For example, we see here which types of standard errors are available with the logistic command, and even see a link to our documentation discussing these options. Further down, we see some examples. We can just copy and paste these commands into the command window to see this analysis in action right away. Let's do the survey example. I highlight and copy the first two commands, then paste them into the command window. I'll make this a little prettier so we can see it better. Then I add the clear option to the web use command to clear the current dataset before loading in the NHANES dataset. Notice that this dataset has already been survey set, so when we run SVY set, it just tells us about its survey features that have already been declared, including sampling weights, strata, and sampling units. We can bring up the Help menu again by clicking the shortcut icon to the viewer, this button with the eyeball. Then I highlight the logistic regression command with the SVY prefix, copy, and again paste into the command window. In the output, we see the sample size and population size and estimated odds ratios adjusted according to the survey weights and sampling procedures. Returning to the Help menu, we also have a few links to our YouTube channel, which I will show you in a few minutes. Then at the very bottom, we have a list of results stored by the logistic command. These are all the details and estimates you can access after fitting your model to perform further calculations, save them for later, make tables, and more. This viewer can also be used to search for community-contributed commands. That is, packages written by Stata users. For example, I can search for the geoplot command and follow the link to read more about this package, and then click to install it. I think we're ready to leave Stata and open our website. Our website has quite a few resources for you, one of the most popular of which is our cheat sheets. To get there, you can search cheat sheets and click on the first result. These contain brief overviews of our most popularly used commands, so they're a fantastic resource to have at hand's reach. Either view them online or download them. Returning to our website, under Support, you can see that we have a lot of other resources for you as well. Let's start with our FAQs, or frequently asked questions. You can either search for a question here in this box, or navigate through the categories below. I can click Graphics and see a list of frequently asked questions about Stata graphics. Returning to the Support menu, you can also access our documentation online, even without a Stata license. If you're brand new to Stata, I recommend reading our Getting Started manual for your operating system. You can either download the entire manual or a specific chapter, such as using the do file editor. We didn't talk a lot about do files today, so here's a good place where you can learn more. Heading back to the Support menu, I also want to point out our video tutorials. The video tutorial page has a link at the top that will take you to our YouTube channel. Here you can see recently uploaded videos, playlists, and popular videos. We have a ton of playlists for different releases, analyses, and even subject areas. Or you can search within our channel for a particular topic you want to learn more about and see in action. These video tutorials are part of our set of learning resources. Heading back to the Stata website, you can see we also offer free webinars, live trainings, both online and in person, and net courses, which are go-at-your-own-pace training. If you really want to dive deep into a topic, I recommend taking one of our trainings or visiting the Stata bookstore. We also have a couple places where you can ask questions. If you have a registered copy of Stata, you can utilize our technical services team by emailing in to ask a question about how to do something specific in Stata. We have a team of experts who are also experts in a wide variety of other fields, like economics, Bayesian, longitudinal analysis, biostatistics, etc., who are all available to support you. Or you can ask a question or search for a question that's maybe already been asked on Stata List. This is our online forum for discussing anything Stata and statistics. You can view this forum without registering and either navigate to our general forum or our Meta forum, our forum for programming in Stata. Last but not least, if you want to stay informed on Stata happenings, you can enroll in our email alerts by navigating back to the Stata website and under Support, clicking Alerts. You can sign up to get emails about new releases and other updates to the software, about newly scheduled webinars and trainings, book releases, Stata conferences, or new issues of the Stata Journal, our peer-reviewed publication of all things Stata. Well, that's all I have for you today. I hope this brief introduction to Stata was helpful and that everyone feels a little more comfortable using Stata. Thank you so much for joining me today. I'll see you next time.